Friends, very good morning everyone. Today let us discuss about Mannich reaction. This reaction is named after this scientist Karl Ulrich Franz Mannich. He is a German chemist. He is a professor in pharmaceutical chemistry from University of Berlin, and his expertise was in the preparation of keto bases, alcoholic bases, and preparation of various derivatives of piperidines, papaverine, lactones, and also worked on digitalis glycosides preparation. He gave this reaction, which is named after him, as Mannich reaction, and he established the mechanism of the reaction in the year 1912. Owing to his contribution, this reaction is named after him. What is this Mannich reaction? This is the conversion of primary or secondary amine and its reaction with two carbonyl compounds, out of which one is an enolizable carbonyl compound, another is a non-enolizable carbonyl compound. In simple terms, a primary and a secondary amine reacts with an enolizable carbonyl compound and a non-enolizable carbonyl compound to give a beta amino carbonyl compound. These beta amino carbonyl compounds are called as Mannich bases. This reaction can be worked out in the presence of acid or base as catalyst. Here, a primary or a secondary amine we take formaldehyde, a non-enolizable aldehyde, means the aldehydes or ketones can be present in both carbonyl form or enol form. Enol form is possible when the alpha carbon has hydrogens. This do not have carbon at the alpha position. Instead, it has hydrogen. That's why it is non-enolizable aldehyde. And an enolizable carbonyl compound. Here there is a carbonyl compound. The adjacent carbon, that is the alpha carbon, has hydrogen in it. This can exist in the enol form too. That's why these are enolizable carbonyl compound. An enolizable carbonyl compound and non-enolizable carbonyl compound, a primary or secondary amine, together react in the presence of an acid or a base to give beta amino carbonyl compound. This is the reaction which is given by Mannich. In other words, it is a method of preparation of beta amino carbonyl compounds. Let us look further into the reaction mechanism. Here, a non-enolizable carbonyl compound reacts with a primary and secondary amine. The carbonyl carbon is electron deficient owing to the electronegativity of the oxygen. Due to the electronegativity of the oxygen, the electrons are not shared equally with the carbon which is attached to it, and that's why the carbon in the carbonyl group will be slightly electron deficient. Oxygen is slightly electron rich. The nitrogen in the alkyl amine or a secondary amine is having lone pair of electrons and it is electron rich and it shares its electrons with the carbonyl carbon. It attacks on the carbonyl carbon and pi electrons moves onto oxygen. As the electrons are given to carbon, nitrogen gains positivity. And electrons are gained by oxygen, that's why it becomes electron rich and O minus. This O minus combines with H plus in the reaction medium and becomes OH. When I treat this with an acid, the protonation of this oxygen takes place. The lone pair of electrons in the oxygen combines with H plus, and once these electrons are shared with H, the oxygen becomes deficient in electrons. It is something like the money what I have given to the adjacent person, I become deficient, right? And to satisfy this positive center, the electrons moves onto the oxygen and the bond breaks over here. Carbon oxygen bond breaks, rendering this carbon positive. As this carbon is positive, to satisfy this positive center, the lone pair of electrons and the nitrogen moves towards it to give an iminium salt. Iminium salts which are formed are stable enough to be isolated. This iminium salt is also called as Eschen-Moser salt. These Eschen-Moser salts are isolated and characterized. And this Eschen-Moser salt formed reacts with an enolizable aldehyde or a ketone. The ketone gets converted into enol form, and this enol form reacts with this Eschen-Moser salt. The lone pair of electrons on the oxygen shift towards the carbon, and it has to maintain its tetravalency. That's a pi electrons shift towards the next adjacent carbon. The alpha carbon here is electron rich, and the nitrogen here is electron deficient. To satisfy the electron deficiency in the nitrogen, pi electrons moves towards it, rendering the adjacent carbon electron deficient. This carbon in Eschen-Moser salt is deficient, and this carbon in enol form of aldehyde is electron rich. That's why they react together. The anion attacks on the carbon and it gets added up. And I have got amino group added at the beta position to the carbonyl group. That's why I have synthesized beta amino carbonyl compound. This is how the reaction occurs. This was being established by Mannich. Hence, the name of the reaction is after him. This has very good applications in the field of organic chemistry. Mannich reaction has been used in preparation of many drugs of pharmaceutical importance. One of them is Rowley tetracycline synthesis, which is the Mannich base of tetracycline. For preparation of Mannich base of tetracycline, the Mannich reaction has been utilized. An antidepressant drug fluoxetine, anti-inflammatory drugs tramadol and tolmetin, azocyclophanes are all prepared by using Mannich reaction as one of the steps in their preparation method. Alpha beta unsaturated compounds or ketones can be prepared by thermal degradation of Mannich reaction product. Then I take diethyl aminobutanone and heat it strongly. It loses ammonia and gives methyl vinyl ketone, an alpha beta unsaturated ketone. This is an example for this. Many soaps and detergents, which are used as cleaning agents and as automotive fuel treatment and epoxy coating phenol polyethyramines, all have been synthesized by using Mannich reaction. This is the gist of Mannich reaction and its applications. Next class we can deal with other reactions. Till then, have a nice day. Thank you.